Let us talk about image processing, the second part, and here we need to talk about more application oriented discussions. And if you see here image processing and the computer vision applications, it's basically talk about three aspects. One aspect is that the application talks about the industry application, surveillance, face recognition, space, and you talk about medical image analysis, automatic vehicle, and other virtual reality and that kind of applications. But one of the common applications is industrial computer vision. What happens in the process of quality assurance when you are producing a product? This quality assurance mechanism works better when you look at this computer vision kind of examples. Visual inspection is done by the machine, so you can identify the faults. Human eyes sometimes we cannot detect, but through computer vision we can actually do visual inspection. Optical character recognition is another very important example of image processing, and practically you understand that it is a challenge in Bangla. We are actually working towards OCR and trying to develop some application towards that, but still there are many challenges, especially when it comes to handwriting character recognition. Biometric is another very important example to see and follow, and I appreciate that you understand that biometric, a lot of applications are available. We still have biometric signatures in our national database, and these are truly applications of image processing. Login without a password, doing the authentication, and producing something very interesting. Fingerprint biometric is very common, and it's happening all around the world, and it's very important because it's actually the biometric signature, which is a very important footprint to follow, and biometrics are honestly applied, but we are still looking forward to very compact biometric representations. Hand-based biometrics, all immigration offices, especially different country, they use this five-finger authentication, hand-based biometrics. And hand-based biometric applications are very wide, and you can see it's actually true application of image processing. Iris biometric is also, one very important signature, because iris has a different signature representation of human. Every iris is different in the world, so this is true image processing applications. Facial recognition, very important area, whereby we have a smart intelligent CC cameras. Face recognition applications like Apple iPhoto can detect faces. You can train it, you can tag it, and this face recognition at various levels. We have applications, starts from visible spectrum to many other areas. Face recognition works also based on templates. You can see these are different templates are created and compared, and ultimately come up with the face detection applications. There are many digital cameras now detect face, and you can tag it. Face detection widely used in Facebook also because of tagging. Gender classification comes at through the face detection. It's happening, and a lot of good researches are taking place. You can see some of the research paper I highlighted. It's IEEE workshop paper. Gender classification is a very important area of image processing. People are working at it. Facial expression recognition is another very important area. Like, from the facial expression, I can actually detect the emotion, whether someone is angry, someone is happy, someone is just out of control, and so on. Smile detection is another very important area to look into in terms of, so you can understand it's a very vast area of image processing. Object recognition, yeah, and object recognition works at different levels. Object recognition truly is one of the very important aspects in image processing. These are actually different examples of object recognition. You can identify different objects. Image segmentation also is a very important example. How do you segment images? And image retrieval, you retrieve the images based on color, shape, texture, and different types of images. Visual surveillance and human activity recognition, very important. These are actually coming into practical application today, and many companies are producing dedicated devices, dedicated technology for this. Human activity recognition happens to be like this also, and these are actually traffic monitoring aspects. These are smart cars, and you can see wide range of applications, vision based interaction and game. AR, VR, augmented reality and virtual reality. True example, automatic panorama stretching, like you can create a big picture taking a series of pictures one after the other. It's such a big picture we created out of taking so many different pictures. An automatic 3D construction from internet photo collection, we can actually create sceneries and scenes based on this. Vision in space, yeah, these are actually different applications which is happening in outer space through NASA and other anti-rover. You see, and initially rover localization. We remember Mars rollover mission, and those kind of things we still happening in NASA. Carrier development. There is a medical imaging, huge application of medical imaging, because you have skin or breast cancer detection from the image. You have 3D scanning, 3D imaging of MRI or CT scan of brain, identifying a lot of interior diseases based on this. So how images are represented, that's very important. It's actually nothing but a two-dimensional data, and it may be 8-bit, it may be 16-bit, it may be 24-bit true color kind of data. These are color images. We know when it comes to color, red, green and blue, three fundamental color images. And these three fundamental color, how actually we do a simple model of image transformation. You can see the light is illuminating a body, and that illumination reflected through camera into a pigeonhole, and this is a pigeonhole kind of camera which captures the image. So what is a visible light? It has a different, you see, electromagnetic radiation, electromagnetic spectrum, and there is a visual wavelength between 400 to 700 nanometer, and this wavelength is actually the visible light range. These are gamma ray imaging. These are different rays which actually pass through human body, but we can hardly understand because of the wavelength is too small. X-ray imaging, yeah, X-ray imaging is another example. Infrared imaging. You have sonic images. This kind of sonic images, we are always having advanced diagnostics, range images, and image formation. There are actually two aspects of image formation. One we call actually representation of color and representation of information. This is a pinhole camera, as we discussed before. So the camera optics, like you have a reflection, and there is a reflection that actually produces an image which you gets corrected. Physics of light is happening like this: illumination of light, where there is a amount of illumination incident on the scene, and there is a reflection of the object. So there is a charge coupled devices, CCD camera, and CCD camera is just static. Camera is captured. There is a frame grabber, and CCD camera plugs in into the camera frame grabber, and this grabber actually helps a lot in terms of capturing the images. So image digitization happens to be point by point, and you can see actually it's capturing the data through reflection of light from the surface, and image digitization follows the same principle. And the digitization, but of course when you digitize you have to produce a noise also, because you may not be able to capture the entire line by line, but you lose some amount of data. Effect of image sampling, you can see original image, and then when you're sampling is gradually deteriorating, because sample by a factor of 8, sample by a factor of 2, and sample by a factor of 4. The decrease is why? Because the sample rate is lower than the required criteria. So effect of image quantization also, the more quantization level, the better representation, but the lower the low quantization level, the poor is the representation. So representation of digital image is nothing but a two-dimensional vector, and these vectors are represented with the function values, and you can see that representing digital image, it happens to be like there are rows and columns and quantization levels, and quantization level is very important, as you know, that it talks about the levels that you produce the value for, which is power of 2. So L is equal to 2 to the power of k, and k is actually the number of quantization levels. So there are image file formats. As you know that image file format has two information. One is header and the data. Header carries first few bytes, and which actually have a very important magic number sequence which talks about a series, and this magic number is nothing but a signature, and this signature, and then you have number of rows and columns, and then the quantization level. So three informations are there in the image header, and you can see common image file formats, PNG and GIF. These are all different actually coding scheme which is used for the images, and you can see here further. So we stop right here, and we hope to continue the discussions.